All right, let's talk about the internal rate of return. It is another important method for deciding whether you should accept or reject a project. Let's first see how it works using this example over here. We have this project which has the following cash flows. It requires an initial investment of $50 and then pays two cash flows in year one and year two worth $30 each. Here's what we need to do, and the discount rate is given to be 10%. Here's what we need to do. We need to figure out a discount rate at which the net present value of this project is equal to zero, and we'll call that discount rate IRR, or internal rate of return. Remember how we calculate the net present value? We discount all of these cash flows separately and then we add them up. So the NPV is just the sum of all the discounted cash flows. So take the first term over here, it'll just remain 50, and because its value is already in the present. And for the cash flow for year one, it will be 30 divided by 1 plus, again, the discount rate we are assuming to be IRR. So I'm just going to put it right over there. And it'll be raised to the power 1 since we are still working in year 1 over here. And then we move on to year 2, where again we have the same cash flow and we have 1 plus IRR raised to the power 2. Now we need to find this discount rate, which we are calling the IRR, or the internal rate of return, such that the net present value of this project is equal to zero. So this whole equation should turn out to be equal to zero. Now this is a complex thing to figure out by hand, and I usually use Excel to calculate it. In fact, I will show you how to calculate it using Excel in a couple of minutes. For now, if you use Excel, the IRR comes out to be equal to 13%. He box that up. That means if the discount rate of this project is equal to 13%, then the net present value of this project will be equal to zero. Now there's something called the IRR rule, which goes like this. You accept the project only if the discount rate is less than the IRR. Otherwise, you reject it. In this case, the discount rate is equal to 10% and the IRR is 13%. Clearly, the discount rate is less than the IRR, satisfies our conditions, so we'll go ahead and accept our project. Now, you can memorize this rule for sure, but in order to completely internalize it, I think it's best you understand what's going on over here. Okay, so now I've rewritten down the equation for you, and I've replaced the internal rate of return with our good old discount rate. But you know what it means, right? Now, when the discount rate, or R, is equal to the internal rate of return, the net present value of this project comes out to be equal to zero. Again, the rule is that you accept the project when the discount rate is less than the IRR. That's when you accept it. Well, let's ask ourselves the question, what would happen if the discount rate was actually greater than the IRR? You can see that the discount rate is in the denominator of these. So when the value of the discount rate increases, the value of these terms as a whole will decrease because the value of the denominator decreases and the value of the numerator remains the same, right? Again, we know when the IRR is equal to the discount rate, the net present value is equal to zero. So when the discount rate is more than the IRR, the value of these terms in the future, this takes place in year one, and this takes place in year two, actually decreases, and the value of your initial investment remains the same because it does not depend on the discount rate at all. So the net present value becomes negative or less than zero. And we already know you reject a project when the net present value is negative. That's why we have the rule that you only accept those projects where the discount rate is less than the internal rate of return, because their net present value then will be positive. All right, let's head over to Excel and see how it's calculated. We have years on the first column and their respective cash flows alongside. The initial investment, $50, is there in year 0, and always remember to add a negative sign in front of the initial investments. The formula is just IRR, and the input will be the cash flows including the initial investment. And as you can see, the internal rate of return for this project is 13%. It's called the internal rate of return since it's specific to the project, intrinsic to the project, and depends only on its cash flows. Alright, hope you got around that, and I'll see you in the next one.